Okay, so here is LeetCode 238, which we have to take a list of numbers and get the product of that list for every element removed in turn. So product of all the elements except the first one, product of all the elements except the second one, and so on. And I'm not going to worry about the time complexity. So here's an example. And the idea here is that we take 1 times 0 times -3 times 3. That's, of course, 0, which means every product will be 0 except the middle one, where we have -1 times 1 times -3 times 3. And we can write this using an inner product. So inner product or dot product usually consists of a multiplication step followed by an addition step. But the APL generalizes this, so you can actually use any dyadic function, or call it binary operator if you want. And that's exactly what we're going to do. So let's get started. We want to create a mask for which elements are included in the product. And then we have one row in the mask, so we're going to make a matrix of masks, and one row per product we need to make. And that means we have to have a false and then the rest of them true, then a true false and then the rest of them true, and so on. So this is like an identity matrix, but the opposite. Let's make this tacit from the outset. That means we're only mentioning the argument in terms of function application to it. This is the tally function, and this gives us that there are 5 elements. If we apply the index generator function and we combine that, as a combinator operator, higher order function that combines these two into a form of function composition. So we apply the index generator to the result of the tally mark. Then we get 1, 2, 3, 4, 5. And then if we make like a multiplication table with 1, 2, 3, 4, 5 going across and down, but instead of multiplying, we can use any operation. So let's first make a multiplication table. We write that like this. That's called an outer product. And then we want to use this argument on both sides of both going down and going across the right. So we do that with this higher order function, which takes one argument and applies it on both sides. And then we glue it together with the other two to make a single derived function, which is the multiplication table of the indices of the length. Instead of using multiplication, we can now use any function. So if we use equality, we get 1s down the diagonal. And if we use unequality, then we get 0s down the diagonal. And that gives us our masks. So we want to multiply the elements that are indicated by the 1s here, and then we want to multiply the elements that are indicated by the second row, and then the third row, and so on. And we can do this directly. We can refer to our argument with the identity function, and then we can write an inner product. So this is just like we would do a normal matrix multiplication, or vector multiplication, but instead of using plus and multiplication, then we are using times and power, exponentiation. And that gives us the result. Other example case was 1, 2, 3, 4. That just works. So this is our solution.